So on this final video, we are going to go ahead and just mix all these techniques around just to make sure you know how to identify the correct technique and so forth. Also, I want to emphasize greatest common factor. A lot of people forget to find that first, and that's really the first thing you should do. So make sure you make a big note, GCF first, or whatever, or just really remember it. That is a horrible T, but you get the point, okay? So let's go ahead and just really practice that, drill that in for these last problems. So first off, this problem has 4 terms. 4 terms, if you recall, means we're automatically going to do grouping method, but even before you do grouping method, like I said, we should look for the GCF. So I'm going to look at all 4 terms. All 4 of these are divisible by 3. So I'm going to go ahead and divide every single one of them by 3. So we've got 3, and then we've got x cubed minus 2x squared minus 9x plus 18. So 54 divided by 3 is 18. Yeah. Okay, and then I am going to go ahead and do grouping method with just what's inside the parentheses. And just as a side note, that 3 is not going to come into play until after I'm just going to bring it down just so I don't get confused. So we've got, let me zoom in a bit. So we're going to find our greatest common factor of the first pair, which is x squared. And you have x minus 2 when you factor that out. Greatest common factor of the second pair is negative 9. Remember, take a negative out if your first term is negative. And then you get x minus 2. So we factor out that x minus 2 because that's the greatest common factor of these other 2 terms. And then you've got the x squared minus 9 as the other one. Now just remember, anytime you have an exponent other than 1 on your factor, you always check to see if you can factor more. Which this one does. It's a difference of perfect squares. So you get x minus 3 and x plus 3. And now all 3 of these are linear, meaning they all have an exponent of 1. So I know for sure I'm done. All right, let's do the next one. So it's 2 terms. So 2-term problems can actually be one of 2 different things. It could either be difference of perfect squares or the sum or difference of perfect cubes. But before we even do that, we need to make sure we find our GCF first. So both terms have a greatest common factor of 2x. So I'm going to factor that 2x out, and I get 27x cubed minus 125. Wow, this looks an awful lot like the one we just did. So it's perfect cubes. That 3, exponent of 3, automatically tells me it's got to be the difference of perfect cubes. So our a value would be 3x. Our b value would be 5. That's because 3 to the third gives you 27. 5 to the third gives you 125. And we just put things in. So we've got 3x minus 5, because you keep the same sign as the original. Then you do the a squared. So 9x squared in this case. Then you switch the sign. So I'm switching from what I just did. So I'm going to change this to a plus now. Multiply those 2 together. So 3 times 5 is 15x. And then you remember the last sign's always positive, and you square the 5, which is 25. And you're done. Because remember, once you use the perfect cubes formula, you can't do anything more. All right, let's go to our last 2 examples. Okay, so this one, 3 terms is usually going to be your quadratic method. So let's just double check that. But before we do that, let's do our greatest common factor, which is, all of them are divisible by a 3x squared. Just going to pull that greatest common factor out, and that will leave me with x to the 4th minus 7x squared plus 12. Now the leading coefficient over here is 1, so I know it's going to be 1 and 1. So really we just have to find factors of 12 that are going to add up to the negative 7. and that will just be -3 and -4. So they're the same sign. So we've got 3x squared because our greatest common factor. And then remember, this is quadratic forms because it's twice as big as the middle one. So I'm going to have it, but you're going to split that in half. So x squared and x squared. So we're splitting the 4 in half to get our new exponent. And then one of them should be -3, one should be -4. And then once again, double check. Anytime you still see exponents, double check to see if they factor more. So it's x squared, so it could be different perfect squares, except that 3 is not a perfect square. But on the second one, we also have a 2, and 4 is a perfect square. So that one can factor more. So I'm going to write those first two down, but this x squared minus 4 will just be x plus 2, x minus 2, and you are done. Wow, this is so fun. Okay, another 3-term one. So first thing you always want to do is greatest common factor once again, which is, now I'm going to take a negative, so all of them have an x. I'm going to take a negative x out because our first term is negative. And then we're going to go ahead and work our magic. So the only factors of 3 are 1 and 3. So there's 3 terms. That's why I'm automatically going to last year's method. Factors of 2, well, I should state before I say that, I'm automatically going because I also see that this is twice as big. We are going to learn another method coming up, synthetic division, when you don't have that relationship where the first exponent is twice as big. But I'm going to keep going. So we got 2 and 3. Actually, I already know I'm going to switch that because 3 times 3 is 9. 1 times 2 is 2. And we are subtracting, so that means one of them is negative. Like so. So I'm going to rewrite my negative x, and then let's fill in the rest. Now it's 3x to the 4th, so you split that x1 in half, so you get 3x squared and 1x squared. The 1 went with the -2, so those should go in opposite parentheses. And the 3 went with the 3, so those should go in opposite parentheses. And I just had too much space there. And then we see if we can factor more. So there's 2 terms, they are squared, so you could do difference of perfect squares if you have perfect squares. Those are not. 3 and 2 are both not perfect squares. Now 9's a perfect square. However, it has to be a difference, meaning a subtraction of perfect squares when there's 2 terms. Since that's a plus sign, you actually cannot factor it anymore, and you would be done.